This is the first video describing the CREATE task for AP Computer Science Principles. I am in one of the two documents that you should have printed. This one's the CREATE task directions. This is basically a couple of pages from the larger directions that are at the bottom of this assignment that you can read over the whole thing if you would like. So first off, your submission requirements, when you do this, you have three parts. You're going to do a video, some written responses, and then you also have to cut and paste your program code. And if you're on the AP website, you'll see that there's 3 spots to do that, whereas there was only 2 spots for the Explore task. So first off, your video has to be in one of these formats. It demonstrates the running of at least one significant feature of your program. A lot of the samples I looked at showed the whole program. Depending on how complex your program is, you might be able to get the whole thing running in 1 minute. Your video must not exceed 1 minute in length and must not exceed 30 megabytes in size. I'm guessing that unless you use some really good video software, if you keep it under the minute, the 30 megabytes won't be a problem. Moving on to the written responses, it says submit one PDF file in which you respond directly to each prompt. Clearly label your responses 2A through 2D in order. So there are 4 different responses you have to write. Your response to all prompts combined must not exceed 750 words, exclusive of your program code. So your program code is not part of this. This actually goes in part 3. You'll see separately from this. So that's not included in the 750 words. When you look through, before I start to read it, one thing that stands out to me, there is no spot where you have to have a bibliography works cited page for this at all. This is really just writing about how your program works and then some specifics of your program. So in part 2A, it says provide a written response or audio narration in your video that identifies the programming language, which if you choose to use AppLab, which we've been working on, would be JavaScript. Some people just wrote AppLab for that in the samples, but technically JavaScript is what you should write. Identifies the purpose of the program and explains what the video illustrates. So first off, 9 out of the 10 samples I looked at from last year used a written response and not an audio narration. I think this is a little easier because you're a little more in control of making sure you say everything you need to say when you're not trying to rush it into a minute that goes with your video. Really your choice, but that's basically what 2A is. 2B, describe the incremental and iterative development process of your program, focusing on 2 distinct points in that process. So first off, incremental, basically you're describing the steps you took to make your program. So you need to say, I did this first, and then I built this part of it, and you need to have a decent amount of steps there, all within that 200-word limit. Iterative means that you made your program, you went back, you fixed something, you added something. It wasn't just like you had this plan in your head and you made a program nice and quick. It's that back and forth of improving your program, refactoring possibly, and that's covered in the second part of 2B. So describe the difficulties and or opportunities you encountered and how they were resolved or incorporated. In your description, clearly indicate whether the development described was collaborative or independent. At least one of those points must refer to an independent program development. Honestly, when I looked at the samples, the ones that had better scores were independent. We'll talk more about the collaborative piece in a little, when we start to get into the program. But if you make something collaborative, you have to make sure that both of you or 3 of you each have your own piece of the program that on its own fits all of the qualities you need to write about. So you do need to kind of build a more complex program, or at least a bigger program, and that might be something that's hard to do since we're doing remote learning. So basically back to this word iterative, that back and forth, if you cover 2 points where you had a difficulty and or an opportunity, so it could be 2 difficulties, a difficulty and an opportunity, any combination of those, that's going to show that you had issues, you went back and fixed it, or you made your program, you saw an opportunity to make it better. That kind of covers that back and forth piece. Moving on to the third part, 2C, you're going to capture and paste a program code segment that implements an algorithm. You're going to mark it with an oval in section 3 below. We'll go over more of the logistics of, getting that oval later. Basically, anything in your program that's an algorithm, you should have some sort of algorithm, because an algorithm is just, sequence, selection, or iteration. If you wrote a program, there is an algorithm there that is fundamental to your program, for your program to achieve its intended purpose. This code segment must be an algorithm you developed individually on your own. So even if you worked with someone, you made this piece of your program. Must include 2 or more algorithms. This is probably the trickiest part. Once we get to the rubric, we'll see. And must integrate mathematical and or logical concepts. So that's not bad. You increment a variable. You test to see if something's equal to or greater than. That's a logical concept where you would get a Boolean true or false there. Anything like that, pretty easy to find something that includes one of those 2 things. Describe how each algorithm within your selected algorithm functions independently as well as in combination with others to form a new algorithm that helps to achieve the intended purpose of the program. So this piece here, where you're finding sub-algorithms within your algorithm, as I said, we'll talk more about in the rubric, but that's kind of, as we read through, the trickiest part of this. On to 2D. It says capture and paste a program code segment that contains an abstraction you developed individually on your own. So when you talk about the algorithm can actually be made up of different parts of the program that already exist, like maybe an event handler or something like that can be a piece of your algorithm. When you talk about your abstraction, it has to be a function you created, a list you created, a variable you created, something that you created as you're writing the code. What's a little different here is with this abstraction. Actually, this part's not different. You must integrate mathematical and logical concepts. The part that's really the focus of the abstraction, though, is you need to explain how your abstraction helped manage the complexity of your program. Okay, also, we'll talk about that more. Basically, how does it make your program run with less complexity, right? Taking away the details, making it run with less code, talking about how, a list can hold all those values in one variable space versus adding multiple variables for multiple things. Anything like that, we'll cover that step. So now we're on to the third part, which is the program code. Basically, you're going to take whatever code you have and copy and paste it into that section. You need to mark with an oval the segment of the program code that implements the algorithm you wrote about in 2C, and a rectangle the segment of the program code that represents an abstraction you developed for part 2D. You want to include comments, or if you can actually build off a program that you've already written or that someone else wrote. You just have to add to it parts that you did. Okay, be careful with that, right? You want to make sure you're making significant changes if you're going to start from something, but you should have comments or acknowledgments for program code that has been written by someone else.